Every first Tuesday of every month, we will learn a new secure engineering skill. Our agenda starts with an introduction to defensive programming, following with the hands-on lab. You can ask your questions directly throughout this stream and receive the links to various resources that we share, especially for the second half of this workshop, inside our live chat. You can find the button to the live chat on our streaming webpage, secteam.com/live. With that, let's begin. I'm going to start by asking a question that how do you feel about security? And I would like to hear your honest answer to this question. Let me give you some choices here. Pain, waste of time, complex, or worst of all, what is security? Now, the reason I started with this because there is a problem. The way that we think about security is specifically when we build a program or a system, we mostly don't see it as something useful or something we have to do. And actually the problem starts there. Let me come back to this question later and ask you another question, specifically if you are a software engineer or working in a development team, what do you like about programming? Now, what excites you about programming and you like to build this stuff? Again, let me give you some choices to pick from. It is like, these are like common answers that I hear that when I run a course and I kind of hear from our engineers about the things that they say to us: art of problem solving, impacting people's life, and just get challenged and obviously pay the bill at some stage. But that problem solving, that things that challenges us to make something, to solve a problem, it's an exciting part of the programming. Now, let me assure you that the security is nothing, or secure programming is nothing apart from that. Let's say we have built a program, and our lovely program, out of many things that the computer can do, will do a subset of that to solve a problem. Now, we have been given the specification, and our program is right there, and that is what we think our program does out of many things the computer can do. Great, we feel good about it. However, in reality, our programs are powerful. Our programs do more than what we think they do. And this is where the problem starts to creep in. Do you want to see an example of a powerful program? Well, we don't need to go far to find one. And I'm sure some of you played this game or have seen this game. Some people are playing. Let's see what happens as this player started this game pretty much on level 1, and what's gonna happen after a while as he is playing this game. It may sound like that he does some random moves here and there, and what just happened there? Well, the end. Right from the beginning, jump to the end. Was it just a glitch that just happened? Or was it just a bug in a program that allows someone to jump from level 1 all the way to the end of the program? Well, the story is not that simple. In fact, the player of this game, or let's call it this powerful program, he or she, by doing all those moves, jumping, moving the objects, getting things and moving them around, she injected the code that he wanted to get executed within that program, and eventually at that final jump that she did, he made a crash in a program and eventually made a jump to that state, which is the end of the game. Now, I don't want to take your time here to talk about really what is going on. There is a big story about that. But this is one example of a powerful program. A program that does a lot more than what the programmers thought about doing so. And people like those players are smart enough to be able to inject their code, their instructions in our program. And we will see soon that the security bugs are nothing different from that. In fact, security bugs are another example of runtime exceptions. That gray area that you see is pretty much where the problem starts. That gray area is the area that what our program actually does, which deviates from what we think our program do. This is the area where the runtime exceptions happen, but worst of all, one of those runtime exceptions are security bugs. Now the problem of the security bugs is that we can't treat a security bug similar to the other type of bugs that we do patching after a while. The problem is quite deeper than that. And I've seen this in quite many code bases that if we treat a security bug the same as other bugs that we quickly go and patch, we will find that that bug will reappear, and we will see an examples of that soon. The problem of these security runtime exceptions, or these bugs that are related to the security, is that there are active actors internally or externally looking to target them. It's not just a glitch. It's not something that it may happen suddenly. It's actually someone actively looking to do it, but the impact of it, well, as you know, is quite devastating. And there is a gazillion stories around that what happened to the businesses when these bugs got exploited by actors. And throughout the workshop that we will have, we will go through these stories and learn about these incidents, that what happened, what was the cause, what was the root cause. And if it happens to big businesses, it definitely happens to a lot of us out there. Now, I want to take you away from what the problem is slightly, and for a moment to think about what, as an industry, or what is the common approach, response is going after and fixing security bugs. Maybe you can help me a little bit with that. Like, what is the number one thing we do when we've been reported a security bug? Either maybe one of our users reported back, or we may have a penetration testing firm. They tested our programs and they figured out the bug, and hopefully we will find that bug before we go live. What is the response? I think I can summarize the response that we have toward the security bugs pretty much in this image. It is unfortunate. We just go run after one bug after another in a whack-a-mole type game, and we're thinking that yes, we have addressed the issue. And that is where the problem actually starts. And don't take my word in there. Let's just look at some example, and I will help you throughout this. What do you think was the security vulnerability in this code snippet? And if you're not familiar with C or C++ code, don't worry, I will guide you through there. There are some comments within there that you can use. This code snippet you see there are two if statements at line 2 and 3 and line 6 and 7. These are effectively the patch that was put in place to fix a severe security bug. Now, those things that you see is like a bit of gray colorish. There are comments that is in the code that may help you to put you on the right path. You can even guess what this security bug is, or what the patch is for. If you have any guesses, feel free to post it on the chat. So the first if statement there, it tries to do a boundary check and an input that is come from an untrusted source, let's say a user, an external user. And second if statement on line 6 and 7 does the same thing, or a similar thing. So effectively, we have two checks there just to do a boundary check. I want to give you another hint. These 4 lines of the code patch a security bug that costed businesses $500 million across the world. Any guesses? Well, the other thing I can point you at is on line 7, there is a comment that mentions RFC 6520, section 4. And RFC 6520 is TLS. I'm sure you by now you most likely guessed what this bug was about or what this vulnerability was about. Yeah, it's related to the memory. Payload can be inflated for sure. That's why we have a boundary size, true. So, Heartbleed. Those 4 lines of patch are to fix the Heartbleed vulnerability, which was a bug on OpenSSL library, a heavily used open source library across many devices and programs and libraries. And this bug, well, this patch was there to fix the issue that the request that was coming from the user was not bounded, was not checked for expected size. And then, long story short, what the response was come from back from the server was, given the size that user is requesting, arbitrary chunk of memory was read from the server and was sent back to the user. And in case there are some cases that arbitrary chunk of memory that was copied back and sent back to the user may contain some, well, secrets in some cases. So the bug was introduced in December 2011, and it went undetected for 3 years up until January 2014. Now, there are fantastic stories and lesson learned about why Heartbleed happened, why we didn't pick it up. This is open source library. This is something that everyone uses. I'm not going to go through any of those. You can read it online. But one thing I want you to pay attention is, if I go back to this patch, do you think these 4 lines of code have fixed the problem, or gives us an assurance that from now on this library will not contain any Heartbleed style bug? And by the way, Heartbleed is known as a buffer overread security bug class. But does this give us any assurance? Or is this another example of a patch, a band-aid approach to quickly fix something and move on? And I'm sure you would agree with me that is a big no, that this sort of way of fixing a security bug will not gonna solve our problem. Let me give you another example of a real story that happened. And one thing to mention, I may make an example of companies and products here, but by no means this mean that this company or product did a lousy job. These are the problems that can affect pretty much every company and a product. It's nothing apart from that. These are like public stories that I could find to relate to our story here. The story of Pivotal starts with September 2017, which there was a remote code execution, or RCE, security bug was reported to Pivotal, which were the maintainer of Spring, or Spring Data REST, to be specifically the library, which is just a library. A lot of people, even not knowing Java, will know Spring. So the bug was reported to them on 7th of September, privately. In matter of 2 weeks, 21st of September, Pivotal went public and released the patch and let users know that they have fixed a severe bug. Please come and download the patch. What do you think happened? Well, the patch was incomplete. The original security researcher went back to Pivotal just in a day, telling them, by the way, your patch is incomplete, it cannot fix the bug. Sad face. In a matter of week, Pivotal again start working on another version of the patch. And this time, privately disclosed that to the security researcher, asking him, can you please verify if our patch was complete? Is complete. What do you think would happen there? Patch was still incomplete, and security researcher could find it out in a matter of a day. This time around, well, the team learned the lesson, and it took them a month to do a full refactor and redesign of that specific library, that part of the code. And here I have a screenshot from their GitHub repo talking about this bug, that they went ahead and pretty much redesigned everything to address that security bug. And interestingly enough, if you go through the comments for this Git commit, they follow one principle which in this course we do encourage everyone to follow, to once for all get rid of the majority of the security bugs that we're talking about. Stories like Pivotal are not, as I said, are not just one. Unfortunately, there are many of them. I don't really have time to talk about all of them. There is another example of Struts. The issue that happened to Equifax was related to the major financial data breach, was actually related to this library. Now, the story is more interesting than the other one, but we just don't have time. Long story short, what is going on? And this comes back to the idea I mentioned earlier, that we cannot treat security bugs like many other bugs that we go after. The problem here is that we do not address the root cause. We just go after the symptom and we think we have cured the problem. But unfortunately, it's just giving a sick patient a Panadol or something for their headache, but not getting rid of the original problem. And security bugs, unfortunately, are quite costly to fix. Not only costly, but also dangerous due to the impacts that they may have to our system, to our company, whatsoever. The other thing is, throughout my career, a decade or so, I couldn't see any even test suites, or when I review the codes, that someone or a team actually write tests for security bugs. Because like many other type of the bugs, these are the things that the program should not do. So I would say the majority of the code bases do not even have anything around testing for insecure properties of their program. And last but not least, the majority of these security patches are pretty much a single layer of defense, unfortunately, which is open to fail. Is there anything we can do about it? Well, yes, there are quite many things we can do about it. And at SecTeam, we have put them under the umbrella name of defensive programming. There are many things we can do. There are many other approaches that we can do that I will talk about it now. The idea here is that we need to bring the security runtime exception early in the development lifecycle. And by that, we need to make those unsafe or weird states. Let's say in that Super Mario game, that state where the code can be injected and moved from a state like level 1 to level N to level the final level, that needs to be an unsafe state that our compiler or interpreter, our test suite, will result in an error that will stop that to happen right at the early development lifecycle. And obviously this will help to reduce the non-deterministic nature of our program. which is quite hard to get rid of, but unfortunately security bugs happen exactly in that area. So the more we can make it non-deterministic, the more we win there. So in reality, we're gonna make our program less powerful. It sounds counterintuitive, but that is what we want to do. We want to follow a number of principles and guides that can help us to reduce that non-deterministic nature of our program. So hopefully those runtime exceptions, those security bugs do not happen. And our program just does the things that it needs to do, nothing more. Defensive programming helps us at different stages of development lifecycle. Right at the beginning, when during the feature inception or a specification of a component being released, it can bring in threat thinking. So it can help anyone, not specifically software engineers, to think about threats by applying a number of practical threat modeling frameworks that help us to pick and identify threats early on. It follows along in a design stage of our program, which it will introduce a number of design patterns and principles similar to many other design patterns and principles that we follow to write our code. But these design patterns, the whole idea here is that to model safe concepts and behavior. It will also introduce a number of, provides us with a number of coding constructs, safe coding constructs or forbidden methods that we should not use throughout our implementation. And finally, and this is the part I like the most, is it helps us to write defensive tests, or let's put it security tests, to discover insecure properties of program. And this is an area I found is quite difficult to think what are those insecure properties are. This is the area that we really need to go and think out of the box. And we will see that it's not the same way that we build the program, that we think about how we need to write a test for it. These insecure properties are the things that our program should not do, and effectively the sky is limit. But there are ways that we can identify it and write a test for it so they can get eliminated. So there are quite a number of things here, and as I said, as part of these workshops that we have, we will go through them. But one thing to remember here is that throughout the years, what we found out is that 2 days, 3 days, 4 days, 5 days type bootcamp does not make a change, regardless of what the training is, who the trainer is, and how the course is being delivered. We just, as a human, we just don't learn in that quick span of time. On the other hand, a self-learn type online platform with a lot of videos and practices also cannot make the change for most of us due to, well, the main reason being we need quite a significant amount of discipline. And if we are doing as part of a company initiative, it requires quite a heavy push from the top to get people do this stuff, and that's not going to make the change. And we found out that what we can do about this to make secure programming a habit. Because by the end of the day, what encourages us, what we are passionate about at SecTeam is to see these changes, to see more codes that are designed and implemented more securely, more than anything else. So we have come up with a sets of practices that, or we call it pathway, to address this problem. It's a mixture of instructor-led classes following with a practice schedule and individual feedback. And this is what we believe is a recipe to help us to make that change, to make that habit. Otherwise, our investment, either as an individual or a team, will not be that effective. We are quite sure that this is quite a powerful technique, because our team is providing both content and delivery to leading education providers in the country to help to build and deliver secure programming course. So we know what actually works, what it doesn't work. Our pass phase, our first pass phase starts with a month's period. Start with a workshop, following with the assessment, and eventual a certificate. This month's period is the smallest amount of time that we invest to learn what we have learned during the workshop, and throughout that 1 month, you will have access to our Learn platform, which I will introduce it a bit later. And you will be assessed for your learning. Effectively, the assessment is rightly timed that you can get, at least in 1 month, the best outcome. And hopefully, you're going to remember it. Our standard pass phase, it goes for minimum 3 months. It starts with workshops, following with the assessment. But what differentiates here is that you will be given at a specific interval at minimum 3 practices. And all of your practices, all your submissions will be assessed, and you will gonna receive an individual feedback for your submission. And this is one of the best ways to find out the areas that you can improve on. And eventually, based on the quality of your submission, you will receive an electronic certificate from us. And finally, our professional pathway, which goes for 6 months. It contains 6 practices throughout these 6 months, following with a game day, which we invite people in a day or a half a day, fun, really interactive attack and defense game to just put everything in practice. And this could be one of the best way for us to make sure what we have learned, it actually stays with us, and hopefully we can incorporate it in our day-to-day code that we write or design. Speaking about the workshops, we have 2 sets of workshops. One is called Defensive Programming Workshop. The focus of this workshop is building secure programs from ground up. We focus on threat thinking, secure design, and secure coding. The focus is a lot on secure design and secure architecture. We're talking about golden or 4 core defensive programming designs here. That is like an 80-20 rule. It will help you to address the majority of the security bugs, whether or not you know about it. So we don't need to chase after one bug after another. We need to know that have we implemented this principle effectively, which is quite powerful. Our second workshop, and all our workshops runs for 2 days. It's designed to write defensive tests. And I'm quite, it's a quite interesting workshop because it focuses on how you can hunt for these security bugs effectively. And this is not about like a penetration testing type course or hacking ethical course. This is quite deeper than that, where we look at insecure properties within the code and how to write a test to eliminate them. Things like coverage-based fuzzing or property-based fuzzing there are the things that we cover in this course. And some of you may have been familiar with property-based testing, so it's effectively fuzzing on a steroid when we are using it for security, for bug hunting. In regard to the threat thinking, as I mentioned, we work on a number of security issues, early detection of these security issues, and threat modeling frameworks, and in a quite interactive way. And our course is filled with lots of labs and hands-on practices, because that is where we think the change can really happen. You will be given access to our Learn platform. Currently, we have nearly 100 modules there, which mix of theoretical and both practical labs across defensive programming and testing. And we will use this platform for the assessment and also for the practices that will be given to you. All your submissions will be through this platform, and your reviews and comments that you will get from us also will be accessible throughout this platform. That was all I wanted to talk about for the first part of our workshop. Now, if you have any questions, you can now post it online. Otherwise, with just a short break, we go to the second half where we're gonna explore one of our hands-on labs. Do we have any questions? Okay, let's move on and come back again. All right. For the second half of our workshop, I'm gonna go through one hands-on lab. If you have already set up your system, well, that's the best way. You can follow along with me. Otherwise, you can watch pretty much what I will take you through. I have picked one specific security bug here to go through it. Let me just bring that up shortly. And just a second, just bringing this up. And this is typically the way that we introduce a security bug is we start with an incident that happened to a company, to a system, but by no means, again, that security, to introduce a security bug, but again, that security bug is not necessarily related to that specific technology stack or that specific company. It's a problem that can happen anywhere. But the story is interesting enough to help us to remember what actually went wrong. So the story is related to the incident related to Android operating system, and the way that the code signature could be bypassed. in February 2013, Google fixed quite a critical security bug in Android that could allow someone to modify a signed app and effectively bypassing that code signature. And this is pretty bad because the whole idea of having a code signature, like, sometimes we have hashes for different files that we download, or by default, all the apps that are on App Store or Google Play, they are all signed. So those are effectively helps us to make sure the integrity of that app has not changed. So this is pretty bad if someone can bypass it. So what was wrong? It turned out to be that on Android, a Java library was used to verify the signature of files in the archive. And by archive, what I meant is Android or Android app is effectively a zip archive, which will decompress before installation. And there was a C library that was used later, right after the signature check, that was used for installation. So can you give me some guesses here that what do you think may have gone wrong here? Where do you think this incident could happen? What could an adversary could do to bypass this code signature? Now, one thing I just want to assure you that this is not related to any cryptography type bugs that perhaps the encryption algorithm that was used or the decryption algorithm that was used to verify the signature of those files was flawed. It was nothing like that. The problem was not related to any, let's say, Java specific issues or C specific issues. It turned out to be that the bug showed itself when there was a duplicated file name in the archive. Quite a rare edge case, right? But for some reason, it is possible to have a file with duplicated name in a zip archive, and I can tell you in many other compressed files we can have the same pattern there. And the default behavior of Java and C was different when they were dealing with the duplicate file name. And behind the scene, the data structure that was used in Java and C were different, and that's why we had different behavior here. So what happened was that Java, let's say we have an Android APK, let's say it's a zip file, it contains multiple files. Like here, I got a file named bar.py, and also I have another file called bar.py duplicated. When Java, we're looking at this APK, will go through the files, decompress it, and anytime across a duplicated file name, will pick the last one or the second one. But C will take the first one. So maybe give me some idea here. As an attacker, as an adversary, how would we go after bypassing the code signature now? Where do you think I should put that? Let's say I want to inject a malicious file is in that APK, or maybe replace one of those Java files or Python files or C files there. Where should I place that? Obviously, it needs to have the same name of the function or file that I want to target. If I build a zip file or an archive that injects that malicious file right before the original file, this incident can happen. Because what happens is that the Java library will look at this APK, will go through all the files, will sort the duplicate, will pick the the original one, because it comes after the malicious one, and this original file has not been tampered, has not changed, the signature matches, and this APK will be passed on to the C library, and over there, the C library will pick the malicious file out, and this is how an adversary was able to bypass the code signature. Now, do we think this was just a mistake in the, let's say, in the library implementation of Android, or in a library implementation of the C, of the like zip archive? Unfortunately not. The problem ends up being quite deeper than that. It is far beyond just an implementation bug. It turned out to be, this is more like a specification flaw within the zip archive. And these days, these patterns of problems, it happens in quite many other places. And I'll come back to it a bit later, specifically with microservices architecture. So the root cause behind the scene is we have a incomplete technology specification. And by that, what I mean is our file format specification, the design document of this file format where a developer will take it and implement it, was incomplete and did not cater for edge cases, some of the edge cases, like in our case, how to handle duplicate files. And incomplete tech specification also can be related to the protocols that our program uses. For example, HTTP is a protocol widely used, JSON is a protocol that is used. And we will see that there are quite a few areas that these specifications are incomplete. The other area that this problem also emerges is inconsistent implementation. So in this case, the design document caters for the majority of the edge cases. However, the implementation varies across different libraries and even languages, which will result into interpretation. Let me give you one example for this. What is the value of action in this URL? Would you say action is transfer? Action is withdraw? Both transfer and withdraw, our program crashes? Which one would you pick? Well, some of you may have guessed it correctly. The answer is, it depends. It depends on what technology stack is behind the scene. And here are just a few examples. That, for example, if we have a PHP with Apache Web Server in front, we will get the last occurrence of the value. If we are using Express.js in the backend, we will get an array of both values. If we are using JavaScript, the Java using a Spring library, it will return the first occurrence. Now the story has become quite more interesting, which we will see in the lab, that we have two Python libraries that we will use to parse the same URL, and these two quite popular Python libraries, they will give us two different values. So what is the problem here? Incomplete specification. Going back to the RFC 38 or the 3986, which is for URI, there is no mandation around how multiple query parameters with the same field name need to be interpreted. So therefore, it is up to the library to interpret one of these values. Let's go through another example. What do you think is the host name in this given URL? Quite tricky to pick, let alone to implement something to do it correctly. Now, just give you one example from Python Word, also using curl command, that if we are using URL lib2 or HTTP lib, they are popular libraries that is used to parse a URL, we will get foo.com as the host name. If we use request, another quite popular Python library, request will return bar.com. And if we are using the ancient URL lib, it will give us baz.com. And obviously, if we use curl to go to this URL, curl will take bar.com as a host name. Now, the problem here is not incomplete specification, but inconsistent implementation. It is tricky to even implement that specification correctly and make sure it's consistent across different libraries. Now, this bug, specifically this security bug, has quite a severe impact and has been used quite widely to bypass authentication and authorization components, specifically if we rely on a service to provide authenticated users to our service. And there are examples out there that this bug was used to bypass web application firewalls, to make the web application firewall interpret the values different from what our program receives. And in general, it's quite a common bug to use to bypass security validation. Now, unfortunately, this bug is not a simple implementation bug, as I mentioned. It is more like a flaw. It is more like a design flaw in the nature of the technologies that we use. And the good news is some security academics, they studied this problem and at least formulate the problem and give it a name. And the name that they have given to this flaw is known as parser differential, which happens when different implementation of the same input language, and let's say input language is that URL that our program receives, is different across different implementation or different libraries. And this flaw has given a rise to many security attacks, and I have listed a number of them here. The incident that we went through early on is known as Android master key. But some of you may have heard about HTTP parameter pollution. It's an example of parser differential bug. This is a type of vulnerability that we're gonna see it more often happening in the microservices architecture. HTTP hostname confusion was the example that I showed to you regarding to the finding the host names. HTTP desync request smuggling, this is another, is an old attack, but recently has given some vibe into it, and some examples of it coming out. And more interestingly than all of them is X509 subject name confusion. This is to do with the way that the browser will verify the TLS certificate, whether they are talking with the right host, the right website. And the confusion can happen, and due to some differentials, the browser may not know that they're actually talking with a different website, or the certificate is not valid for this website. I'm going to take the first attack and go through a lab together here. And HTTP parameter pollution is when the example that we had earlier with that action. It happens when the request parameters with the same field name are interpreted differently. Now, to continue on, and that was pretty much I wanted to talk about, talking about the theory of this. I want to move to the lab. For the lab, we're going to head to our Learn platform. I will post a link to this place here. You can go there. And you can choose the lab from any of these languages that you are more familiar with. For our case, I'm going to take the Python. And out of Python, I'm going to go to this lab, code signature bypass. And well, effectively, all the labs, they start with an introduction, which pretty much what I have already covered, following with the lab itself. So let me just log in here. And here we go. So what I want to do is this is the lab guide. So effectively, if you want to do this lab on your own, these are pretty much the steps that you can go through, and it will take you through to do the lab. It starts by pressing download and cloning this URL that will be given to you. Now you will be giving the HTTP URL, so you don't need to have SSH key for your case, but in my case, I need to have SSH key for that. All right, so let me move to my terminal here. I've already cloned the lab and have it locally. The first thing, I'm pretty much following the guide here. So task number 1, we need to build the program. And then and then make test, and finally make security test. Let's just do all of them. Make build. Okay, program is ready. And we can do make test. This will run the usability test, just it makes sure that the program runs as expected. Yeah, it seems like everything works well. And let's run security test. This will make sure that the program, well, it has an example, one example of the security bug, and it will test for that. This will just show that okay, the program is still vulnerable and we need to do something about it. But before any of those, I want to run the program. I just need to make run. I will do it in a different window so I can follow along my other commands that I want to run. So effectively, you want to just run make run, and once the environment is up, here we can interact with the program. I'm just going to use curl, no other fancy tools to interact with the program. So it runs a web application, a Django-based web application on port 8080. And I need to give it a correct path to go, so it's not program. Okay, here it's giving me some ideas that where I need to go. So I can pass in an action value, a value transfer, and an amount. And also I can specify any amount between these two. And also I can do, well, I can only do transfer. I'm not allowed to do withdraw. So let's just try this. Transaction and action equals to, let's say, just use the exact same example that they had up there. And amount equals to 100. Well, I can see it ran successfully and transferred $100. Maybe make that 1,000. Well, that also ran successfully. What if I change these to withdraw? No, it's not allowed. You can only transfer. So there is a logic here that telling me that it does not allow us to do any withdraw action, which makes me wonder, is there any way to bypass it? So if you remember from the examples we went through, can I duplicate one of these parameters and see if I can bypass this check? So let's say I put action equals to transfer, ampersand, action equals to withdraw. What if I change the order? It didn't happen. What about now? Whoa, it seems like it's possible now. Successfully withdraw $1,000. Let's see what is happening. Now, this lab contains two services. One is called verify, the other one called payment. So think of it, this is like our internal payment, or that does just the transaction, whatever transaction comes through. This one is our gatekeeper, the one that makes sure only authorized payments come through. and this one is not exposed, this service. The verify is a service that is exposed, and it will communicate with payment through a private network. The source code for both of these services are here. Imagine the payment in reality will be something that maybe another team in our company may work on, but verify is the component that we control. Let's look at verify for a moment. So if I go into is a typical Django app that you have everything within your program name, and here we can also see both tests that we have executed by running make test, which run this test for us, and make security test, which run the other test for us. If I open up, let's say, our security test, I want to see what actually failed that test. I can see two sets of tests here, which is just two examples of how you can test for HTTP parameter pollution. This is again just two examples. We are not talking about testing for insecure properties, which I will come back to it a bit later, which is quite interesting. So the first test is expect that if we supply withdraw and transfer at the same time, we should get 400 back. And if we do the same thing but in a reverse order, we should also get 400 back. So that verify component should handle this. And there is a test here that is missing. That this is something that you should control. This is another way that someone is able to trigger HTTP parameter pollution. Now let's look at the app itself, and it's quite a basic app, and we keep all these labs quite simple so you can quickly figure out where the problem relies. Now if I look at this code here on line 12, this is where the transaction is hit, and there is a check that will check if the action request.get action equals to transfer. If so, it will pass on using requests library, it will pass on that value and the amount, like that original request, it will pass it on to the payment component. It looks fine. I mean, there is no something that we can immediately pick. Well, obviously we can have a cleaner code here, but in general, it looks fine. Now, let's have a look. As I said, this is a Django library here. Let's have a look at the other component. Sorry, the other service here. If I go to the payment, this is quite a simple program. It only has a single file, and it uses Flask. And the logic, very, very dumb. It effectively looks at a request parameter. It will take action, put it here, and take amount, put it here. And as I said, it's a general transaction type service which does both withdraw and transfer regardless. Now, our goal here is that from here on, we need to, first of all, go to our verify component and start completing this test. I'm not going to do it at the moment. I will show you where you can find it. But firstly, we need to write another test that will test for exactly same example, but through URL encoding. I will show one example later. Now, one thing perhaps we may be very tempted to do here is that, well, to fix this bug, I can just jump here to the place that the problem happens. Now, first of all, let me ask this question. What do you think these bugs happen? Like, where do you think that the problem relies? Is it in the way that we do this check, or is it the way that we are passing on these values? Which one would you pick? Or which one would you will stop, actually? There are many ways we can stop this bug. Well, one of the easiest fix would be to go here rather than pass on a original request to the payment component, we just pass on the first occurrence of that action and of that amount field. And that will most likely pass those tests for us, and we may have an amazing feeling that yes, we have fixed this bug. But this is one example that I want to say, this is just an example of how we have a band-aid approach of fixing this bug, because this approach of going after trying to fix this problem, it has not got rid of the underlying problem here. If tomorrow I have another endpoint here that maybe does withdraw or maybe does canceling a transaction, the same problem happens, I have to be always on alert that whoever write this piece of code does not pass on the original request to other dependent services. And this is one of the examples that I just wanted you to pay attention that this way of fixing is not going to get rid of problem. Is there anything else that we can do? Yes. Let me go back to our slides here. So how do we detect this bug? I've already showed it to you. HTTP parameter pollution is relatively easy to pick during runtime by simply duplicating the parameters in the query string, as you could see in the demo that I did. You can also do the same thing when we are dealing with a post request. And one thing just to take away as a bonus here, we have the same problem with HTTP headers, that duplicated HTTP headers are interpreted differently by different services. There was an example of authorization HTTP header, which is a header heavily used to pass around tokens, JWT claims. And the service which was authenticating was in charge of authentication, if it will come across a request with duplicated authorization header, may pick the first one and will make the validation of that and will pass on that original request to the internal service, which will assume whatever comes through is already authenticated and will look inside that authorization header to pick the username or user ID. And that system, that service may have picked a second authorization header, which could be maliciously modified and point to a different user, but that is the token that is not validated by the authentication service. This was an example of things that actually happen. Similarly with the cookies, and if we have multiple services looking at the cookie, duplicate them and see how the programs or the services behave. Changing the order, or what you can do, you can encode the special characters. Anytime you see seeds, these are effectively some of the example unit or integration tests that we can take to improve the security tests that we have in the labs. So in the example that we have example of this and this, but we are missing still on these two examples. So this is something that in our full workshop we actually go through and implement. Okay, so I mentioned that how can we effectively eliminate this bug? Obviously we do want to avoid going and putting a single patch there. Is there anything that we can do to once and for all get rid of this insecure property completely? The good news is, yes, there are. And there are a number of defensive design patterns we will go through throughout our workshop to effectively make that behavior, that insecure interpretation, completely impossible in our program, and gives us a guarantee that regardless of what endpoint will be explored, how the code will be refactored, that unsafe behavior will not appear again. And finally, defensive testing. Let's say we have been given this program, but this time around we want to go back and write some effective test for that insecure property that we have seen. Now the problem of that test that we had there, let me go back to the test again. Let me open this one again. The problem of this test is that these are an example of example-based testing, that you give it some sample, let's say some proof of concept, whether or not vulnerability exists. But the problem here is that these sort of testing are not testing for the bigger picture. And I'm referring to that as an insecure property. These are just a few examples. And there are many ways to write different examples to just again show that this program is still vulnerable. Can we write a test? Well, a security test to effectively test for those. And this is a discussion that we want to have in our defensive testing. How we can hunt for that insecure property. Like if tomorrow our code completely refactored, and let's say instead of query parameters, we will be given a JSON as an input, or we may be given a protobuf type input, or we may be given GraphQL, because HTTP parameter pushing can happen in all those cases. Is there anything we can do to guarantee us that, or write a test that, okay, this problem, regardless of what input language you're gonna use, is not gonna happen? If we think a bit deeper, this problem happens that when we have at least two services, the first service does a validation and pass on the original request along to the second service. And depending on how it is formulated, one of these values, bar, baz, or both of them will be validated, which we don't know about. The insecure property of this bug relies in whether untrusted parameters are passed versus parsed or interpreted values are passed on. So if the same parameter in the original form passed to those other services, it is likely that we're gonna see this vulnerability again. If the interpreted values are passed on, it is likely that we will not be vulnerable, regardless of what input language is being used. Is there any way for us to test for this? So rather than just have a few examples of withdraw or transfer, is there any way that we can test for this? And bear in mind, for example, another HTTP parameter pollution attack happens on the amount field, which we didn't even have a test for it in our example. Again, throughout the course, our defensive testing course, we talk about a number of tactics that we can use for testing. And one of the tactics it's super powerful here to completely eliminate this problem is known as differential fuzzing. It is similar to a tactic known as, they call it the test oracle. It's a version of it. But effectively, the way that we're gonna refactor that test is we're gonna write it in such a way that we're gonna give the same input to both of these services, let's say action and payment, and we're gonna see what outcome comes out of them. If the output they are equal, happy days, we don't have HTTP parameter pollution. If not, we highly likely have a problem there. And with this type of testing or this property-based fuzzing or this tactic, we can make sure that, okay, we have got rid of that property and eliminate that sort of bug. Obviously, this was just one example of many other type of attacks that we will go throughout our workshops. For each of the labs that you can see here, we start with an incident, a real-world incident, following with a bug. This is one of the best way for us to remember this bug, because some of these security bugs or vulnerability do have quite a confusing name, but we do remember the incident that they were related to. And depending on whether we do the defensive programming course or testing, we're gonna either go and effectively patch that bug, hopefully not using any if statement in our code, or we're gonna go ahead and write a property-based type test to completely eliminate that bug once for all, or at least test for it, which is quite a powerful technique. Well, that was all I wanted to talk about. We have went through quite a few things. I hope you got some ideas about our workshops and also learned something new. The platform is accessible for you. You can go now, register and use any of these labs. The majority of them are open and accessible to public. You can use them. And if you have any questions, you can still ask your question in the chat channel. This chat is always live, and we will look inside them. Thanks so much.